Anil, what's up?
Yeah, Dev, I'm fine. What about you?
And what are we discussing today on Video Geeks? What's the
So,
hot today?
yeah. So from the last two videos in the video gigs, I am presenting STP. So I'll review what we have seen till now, and I'll just move on to the enhancements of STP that has been made till now. Hopefully, it will be very
Yeah.
interesting for everyone. So you were there in the first video, right?
Yep.
So how much do you know about STP?
Currently, I am fully blank.
Okay,
So
okay, okay. No problem. So
you
I'll
you just might want to also for the viewers, you just might want to in 2-3 lines maybe revise sort of two videos.
yeah,
We
yeah.
will provide a previous video in description, but let's just speak over some lines about.
Yeah, we'll quickly revise what we have seen till now. So in the very first video, we have seen these three terms: transparent bridging, unknown unicast and broadcast, and the very basic overview of STP. So we have seen this
Yep.
term. What is we have understood what is transparent bridging. We have understood that what are the cases when switch will broadcast the frame. We have took this example to understand the very basic working of STP. We have assigned this much port roles, and this was the final topology. And
Yeah.
that was the first video basically. So in the second video, hopefully, like, I think you were not there in the second video when actually we were recording it. It is out today only. So this was the second video. In the second video, we have deep dived into STP. We have understood we have understood this much, these many terms. What are BPDUs? What is root bridges? What are port roles? What are port statuses, bridge timers, and the structure of spanning tree. So these were BPDUs, type of BPDUs, topology change notification, topology change acknowledgement. These were the port roles. These were the port activity statuses. So hopefully our audience knows this much
Yeah.
stuff, and I'll ping the link of both of the videos in the description. So if you have not watched that video, so it will be like a click and go for the viewers. These were bridge timers, and we have did the practical stuff with the Cisco packet tracer. And actually we took this topology only in the example, and we have seen that how this topology is formed in the STP, sorry, in the Cisco packet tracer. We have observed the packets also. So with that, let's start today's video, and we'll understand what STP working first, what are the steps that STP goes through, and then we'll look at the STP enhancements. So let's start. So in today's video, we'll see what is BPD flood, root switches selection, counting least cost to root port, and these are the STP enhancements. So we'll look at all of this. So if we talk about the STP, then STP goes through many phases. But to understand, I have breakdown of in few steps. So basically, these are not actual steps. This is just for understanding that I have break it down. So mind well. Okay. So according to STP, this is the first step, that each switch will generate BPDU IDs, which is like mixture of priority number that is being selected by switch itself and the MAC address. So the combination of this priority and MAC, it is known as BPDU ID. And default BPDU priority number is 32768. That is elected on Arista switches, like by default configured on Arista switches. So you
Yeah.
can see if this is the topology. So by default, all the Arista switches, that they will select this priority number by default, and this is called this is like to separate. This is the priority number. And let's say this is the MAC address. imaginary MAC address, basically A, B, and C. And let's say when the BPDUs will be exchanged, so in that packet there will be destination multicast MAC, which is the special MAC address that is being used. So this is
Yeah.
multicast MAC. And note how this pair is working. This is priority number and this is MAC. And combinedly this, it is BPDU ID. Okay. So this is step 1. So each switch will select this BPDU ID. And now in the STP of step 2, switch will uh, with the least bridge ID, or you can say the MAC, will be elected as root bridge. And non-root switches will now stop sending BPDUs. So this is step 2. So in step 2, let's say these are the 3 switches, and out of all of these 3 switches, the priority numbers sorry, the priority numbers are same. You can see 32,768, that is selected by default. But the least MAC address is this A. So this switch
Yeah.
will be elected as root switches after the BPDU exchange has been done. And now these two switches, which are non-root switches, they will now stop sending BPDUs. Only this switch will now send the BPDUs, and all the ports of these switches will be assigned port roles designated. So this is D. That's why I've mentioned this D over here. And this will be
Yeah.
root bridge. So that is step 2. Now the step 3 is non-root switches will elect root port. So all the non-root switches, so this switch and this switch with the MAC address B and C, they will now elect the root port. And root port that we have seen in the last video, which is the closest port to root bridge. And
Yeah.
now how they will elect the root port to and they will basically create the cost, and by after that cost they will elect the root port. So the cost is calculated by this matrix, and the matrix is, let's say, the port bandwidth with respect to the cost. So let's say the port bandwidth is 10 MB, 10 M, 10 M port, so 10 megabytes per second. That is the very basic older Ethernet ports. So cost of that port, if the let's say this port is having 10 MB bandwidth, then the cost will be 100. Let's say 100 M, then the cost will be 19. If the port is 1 gig bandwidth, then the cost will be 4, and 10 gig bandwidth, the cost will be 1. So this is the matrix, cost calculation matrix. And let's say if you assume that all the switches, all the ports of all the switches, they are having 1 gig, sorry, 10 gig port, 10 gig bandwidth, then this cost will be 1, this cost will be 1, and this cost also will be 1. Okay.
Yeah.
And if we calculate via this, so for this switch, if it chooses this path, then the cost will be 2. And if it chooses this path to go to root bridge, then it will be 1. So Ethernet 1 port of this switch will be elected as root switch because the cost is less. And same, it will happen for this switch. If it will go via this path to the root bridge, then cost will be 1 and 1 2, because we have assumed that all the ports are 10 gig bandwidth. And if it will go via this port, this path, then it will be 1, cost will be 1. So this port, Ethernet 1 of this switch, will be elected as root switch, sorry, root port. So
Yeah.
that's how non-root bridge will be selecting their root ports. So this is the, let's say, if the costs are same, then it will be go for switch ID. So let's say cost of this and this is same. Let's say this switch will have two paths for going to, for reaching to this root bridge. Then it will select the path which is connected with the less switch ID. And switch ID I mean by this uh, combination of priority number and MAC. And let's say switch ID is the same, then it will go for the least port ID. So let's say this switch is having two paths, and one both of the path is connected to, let's say, same switch ID, then it will
Yeah.
select the port least port ID. Let's say if this switch is connected via this somehow, let's say Ethernet 2 and Ethernet 1. So Ethernet 1, it is having least port ID, so it will be selected as root port. So that's how the election of root port is being done. So now we have this port role assigned to it, designated, root and root. And now the last is step 4, which is to non-root switches will now assign other port roles. So first it will assign root ports, then it will assign other port roles. So other port roles are designated, alternate, or backup. So these three will be assigned. So for that, if let's say port is connected to least switch ID, it will be selected as designated, or port with least cost to root bridge, that will be designated, and other ports are all alternate.
Yeah.
So let's say for this path, this port, the MAC ID of MAC, so the priority number for both of these switches is same, 32768, but MAC of this which is B, which is lesser than the MAC of this which is C. So this port will be assigned designated, and this port will be assigned alternate. And that's how we have the whole entire STP topology, and these are all port roles assigned to the ports. So that is how STP works. So these are 4 steps,
Yeah.
and that is the basically working of STP. So if we move to STP enhancements now, so there were lots of enhancement in the STP that we have seen. So the first, uh, like let's say when there will be some topology change, let's say this port has gone down, then STP will select this. STP will change the port role of this alternate to, let's say, root port, because this switch, root port of this switch is, like, let's say, turned down and turned off, or something else has happened. So in that case, when STP topology change send the topology change notification, it is like it will take 50 seconds to detect that this port has failed, and it will recalculate all that stuff. So before it
50,
starts to
50 seconds.
recalculate this, yeah, yeah, because there are lots of timers. It will have to wait. There is something called dead timer. So it will wait 20 seconds for dead timer, and
Yeah.
after that it will wait for 10 seconds. There are lots of timers. So basically 20, 20, and 10. It makes 50 seconds for the switch to wait. The first one is dead timer. Then second one is, I don't know about other tools. What are the timings? So
Yeah.
basically 10, 10 seconds is for recalculations, 20 seconds for that timer, and I don't know about the 20 seconds, but it will basically take 50 seconds to detect and before it recalculates.
Yeah.
And in rapid STP, it will take 20 seconds. So basically they have reduced the time before it
Yeah.
recalculates in case of there is a topology change. So that is basically enhancement of STP, one of the enhancement, that they have reduced the reconvergence timer. So
Yeah.
basically it will recalculate if there is a topology change very faster compared to the actual STP. So that is known as RSTP, or rapid spanning protocol. So that is the first
Yeah.
enhancement.
Yeah.
And the second enhancement was per VLAN STP. So STP was like, first it was not based on the VLAN, but nowadays the second enhancement that was made in STP, that per VLAN you can create spanning tree. So let's say for VLAN 1 we have one spanning tree, and VLAN 2 we have second spanning tree. So that's because for the each VLAN will have different traffic flow, and for different traffic flow we can choose different route switches. So that was the another enhancement of STP. And now we have rapid also spanning tree, and per VLAN also spanning tree. But this was known as PV-STP. But this
Yeah.
was the enhancement of older STP, not the rapid STP. So then this, to reduce the convergence time in this, they have enhancement. They have did enhancement on rapid STP and created rapid PV STP. So in that also they have did the same enhancement, like to reduce the reconvergence time and recalculation time. So that is, these are the enhancement of STP. And other than that, they have introduced some new features in the STP. So these were known as other these are known as other enhancements. So first is port fast. So let's say when this switch is connected to end user over here, and that uh, end user is, let's say, idle, then the port will
Yeah.
uh, turn off. And let's say if it will start sending some packets, then port will turn off. So continuous flickering will be there. Port will turn on and off, turn on and off. So if that is happening, then STP will note that there is a topology change. So it will recalculate uh, per interval of time. Like whenever the port will flicker, it will recalculate the topology. So there will be TCNs and TCA packets flooding all over the network. But we know that there is an end user after that port, so we can configure port fast on that port. So it will basically tell the STP that there is an end user, and you do not need to track the change of that port. So that is the port fast. That is one of the new feature that was introduced into STP.
Yeah.
Then there is a yeah. Then there is a BPDU filter and BPDU guard. So BPDU guards are like, let's say, if you have configured some port to be port fast, and then let's say you by mistake connected that port to some another switch, and let's say that switch will start sending BPDU packets because that switch is also running STP. And if
Yeah.
let's say if the port is configured as port fast and it will receive BPDU packets, then it will be like you can say error kind of thing, because it should be not receiving the BPDU filters because it has configured to be port fast, so it should be connected to end user, and it will not accept BPDU packets from that port. And if it receives, so if we have configured BPDU filter on that port, so these are all filter let's say features that we can configure on port. So let's say if we have configured BPDU filter on that port, then it will go for the error disable mode. So it will basically shut down the port. So that is BPDU filter. Let's say if it receives by mistake the BPDU filter, then it will be down. Port will be going
Yeah.
to like shutdown. So by that we will come to know that yeah, we have configured port first and we need to change that. And in order to change
Yeah.
that,
Yeah.
we just need to turn off that port and turn on that port. And that is if let's say we don't want this port to be go for the shutdown mode and accept the traffic, then we can configure BPDU guard. So basically it will give warning, not turn off the port, not shut down the port. So that is BPDU guard. And
Yeah.
another one is loop guard. So let's say we have something called loops. So where if the port is like let's say alternate, then also we can have some loop packets. So to avoid that, we have loop guard enabled on this some port, which can particularly cause loop. Then we have root guard. These were all the enhancements. So root guard is not like uh, much to discuss on that. And then the last enhancement was made, that is MSTP, multiple spanning tree protocol. So that is the enhancement of this rapid PV-STP, per VLAN spanning tree. So let's say we have uh, more than 100 VLAN configured on these uh, devices. So we will have 100 spanning trees. So there will be different root switches for all of these 100 VLANs. And let's say if we want to avoid that, so we can group VLANs, like let's say for VLAN 1 to 5, we have this root switch. VLAN 10 to let's say 25, we have this root switch. So that is multiple
Yeah.
spanning protocol, MSTP. So that is also enhancement of this STP. So these were the things for the STP. Hopefully you have got the idea of working how STP is working in detail, what are the enhancements that has been made, and what are the latest feature that you will get if you want to configure the STP. So with that, this was the all about STP. We have included 3 videos. This is the last one. You can watch other videos also, first part and second part. So yeah, that was it from my side on STP.
Yeah, very great overview of STP series. Thank you, Henry.
Yep, yep.